Hi, and welcome to the third tutorial on MTurboReverb from Melder Production. This time we're going to discuss its major part, the late reflections generator. That is the part that influences the reverberation most of all. As you can see, there are 6 of them working in parallel. The generator is built upon a very complex feedback delay system, and if you know how to control it, you can even write your own algorithm. It may seem difficult, however, you don't have to be a software designer to do that in MTurboReverb. You will find a few built-in assistants that help this process considerably. We'll get there eventually. For a start, let's learn simple things. Generator's parameters. The first parameter we're going to talk about is the length. It is accepted that the reverberation time is specified by the time it takes the reverberation to decay to minus 60 decibels, and that is what this controller sets. The higher the value, the longer the time. I must mention to not take this value literally though, as the actual reverberation time depends in many respects on the algorithm. The complexity controls the structure of the generator. As with the length parameter, its action depends on the selected algorithm. In most cases, it affects the density of the reverberation by controlling the number of delay taps. The size determines the time of the delay lines used by the algorithm. It is named a size because in the real world, the size of a room defines the time of reflections. The larger the room, the longer it takes for reflections to travel from one wall to another. Both this and previous parameters influence the reverb density, but in different ways. The pre-delay parameter sets a lag between an input signal and late reflections. Here, it can be used to make some space for the early reflections coming from the early reflections generator before the late reflections kick in. I'll show you what I mean. I set the dry-wet parameter to 100% so we can concentrate on the reverb sound. First, let's get some early reflections from the early reflections generator. The early late controller is at 0%. Yeah, I'm happy with that. I put the early late controller to 100% and move to the late reflections tab. And this is the sound of my late reflections generator. The pre-delay is 500 milliseconds. However, we can't really feel it because there is not a reference we could use. Now, if I set the early-late parameter to 50%, we will hear 2 distinct parts of the reverberation, early and late reflections. This is a very unnatural sound. To make it sound as it should, I'm going to reduce the pre-delay to the value when the early reflections have just enough room before the late reflections come in and the whole reverb becomes a single monolithic sound. "30 milliseconds work for me. I don't think I need to explain the volume and panorama. The widening employs the MS matrix to control a width of stereo image. At the far left position, it makes the output mono. "0% gives a wide stereo image. At 200%, the image becomes even wider. The cross slider controls the role of the input channels in forming a stereo image. At 0%, the output of the left channel is defined by the left input signal, and the output of the right channel by the right input. At 100%, both inputs are equally processed by both channels. And at 200%, we get a reverse situation when the output of the left channel is defined by the right input and the output of the right channel by the left input. There are two signals which the late reflections generator can process: the dry signal of the plug-in or the combined output of the previous generators. The processing always goes from the left to the right. In this regard, the previous means all generators located before the current one. The input controller defines the signal which your generator processes. If it is set to 0% previous, 100% dry, the generator will only process the dry signal. At 100% previous, 0% dry, only the signals from the outputs of the previous section will be accepted. Finally, all intermediate values set some balance between these two signals. That allows us to use the previous and current generators like two independent processors, delay and reverb for instance. In the next example, I use the early reflections generator like a delay effect. The late reflections generator produces a room-like sound. Now, if I move the input slider to the right, I'll add an extra feed from the early reflections generator. Here is how it sounds. The output sets the balance between the outcome of the previous and current generators. It works as the early-late controller does in the global parameters pane. However, its influence extends only to the currently chosen generator. At 0% out, 100% previous, we hear only the work of the previous generators, provided the early-late controller is in its middle position. If it is set to 100% out, 0% previous, then we will hear the current generator, and all the intermediate values set the balance between these two modes. The modulation pane contains parameters controlling the modulation of an input signal. If it is off, the generator receives the input signal in its original form. When the modulation is enabled, the input signal gets modulated by a built-in low-frequency oscillator. Commonly, it is used for reducing a comb filter effect, appearing as the summation of an original and its delayed copies. Also, the modulation can create a pleasant chorus effect in the reverberation. When overused, it makes the reverberation sound bizarre or even ugly. So far in my examples, I used the late reflections generator in a straightforward manner. That is, we have been hearing pure reflections without any alteration, and you have noticed, of course, their bright nature. However, it is never the case in real life. The reflections always undergo a few changes. They get limited in a frequency range and energy. The dampening low-high and low-high pass groups of filters are meant to imitate the first part. They emulate absorption of an air and surface materials, but differently. In my next example, I'm going to stretch their effect in time, so you can easily understand the difference. Here is the reverberating sound of a bass drum and hi-hat playing together. It is bassy and bright at the same time. The only change we hear is the reverberation energy decay. Speaking of its spectrum, it stays the same. Let's start with the dampening high parameter. When on, the high frequencies will get gradually reduced. The low-pass filter cuts high frequency as well. However, in contrast to the dampening high block, the effect it brings is static. In much the same way, the dampening low and high pass work. Listen to the effect of the dampening low parameter. And now the high pass filter. Like I said, I purposely used a long reverb to show the effect. For a successful emulation of real spaces, you need to use all 4 modules. In the next tutorial, we are going to discuss the generator's core, the designer. Get ready to become a software developer. Thanks for watching.